This broadcast has done extensive reporting on the effects of climate change, and our attention was recently drawn to the Arizona desert.
A project to bring freight rail to northwest New Mexico has been deemed feasible. The Four Corners Rail Project would establish freight train routes between the region and the I-40 corridor.
The Four Corners region, where Arizona, New Mexico, Colorado, and Utah meet, is a landscape of dramatic meeting points. Cultures, geologies, climates, and histories intertwine here in a way found nowhere else. Vast mesas cast long shadows over winding canyons, and silent stone ruins lie beneath expansive blue skies. Renowned for both cultural richness and unique geology, the Four Corners has fascinated indigenous residents, travelers, and scientists for generations. In the heat-choked summer of 2025, however, the Four Corners finds itself at the nexus of a new phenomenon, one as alarming as it is uncertain, a relentless surge of heat, raising questions not only about what is happening above ground, but what may be unfolding underground as well. In July, the official weather station near this region recorded a staggering 118 degrees at 3:45 p.m., the hottest day so far in 2025, and a temperature that exceeded prior records across Arizona's arid lowlands. Parched surfaces and hidden subterranean layers alike are affected as temperatures smash once solid thresholds. On the landscape, wildfires sparked by lightning race across the western slope in southeastern Utah, chasing through dried brush primed by hot winds. The iconic North Rim of Grand Canyon National Park, typically alive with summer visitors, now stands shuttered for the rest of the season, a stark representation of nature's volatility. All of this unfolds amid mounting drought, a heat dome stretching across the western U.S., and ongoing stresses to water, ecosystems, and communities. What is fueling these record heat waves? Why does the Four Corners seem like a focal point for such extremes? And could there truly be something happening beneath the ground as well? Are there unseen processes at work below the plateaus and valleys, quietly changing the landscape in real time? Let's follow this unfolding story of the Four Corners as we seek to understand what lies beneath the visible extremes. The Four Corners, a region defined by extremes. At the precise intersection of four states, the Four Corners region is truly a mosaic of geological formations and cultures. Sandstone buttes stretch toward the sun beside broad mesas, while ruins of the ancestral Puebloans nestle in cliffs and caverns, their walls whispering of lives lived long before European settlers arrived. Modern-day Navajo, Ute, Hopi, and Zuni peoples continue traditions and stories older than the mesas themselves, reinforcing the deep cultural connections to the land. The geography here is particularly striking. Carved by rivers and uplifted by ancient tectonics, the land is shaped by both fire and water. The full range of the Southwest's climate is on display. Winter months can bring mild days with rare snow or rain, but unpredictable extremes have always demanded resilience. Yet recent years have seen unusual escalation. In 2024, for example, Phoenix endured a record-breaking 113 consecutive days at 100 degrees or higher, a feat that redefined what constitutes a southwestern summer. Now, in 2025, the situation is even more pronounced. Aridity dominates. The sun strips the ground of moisture, and rivers shrink to a fraction of their flow. The July 17th, 2025, Drought Monitor offered no relief. Drought conditions worsened across the Colorado River Basin, threatening water supplies that sustain entire cities and countless wild habitats. What makes this heat different is not just its intensity, but its persistence. Every day without meaningful rainfall dries the soils deeper. Each night, the high air and ground temperatures barely abate, leading to relentless heat stress for ecosystems and humans alike. There are growing indications that this upsurge in heat is not limited to the air or the ground surface, but may extend to unexpected depths, raising questions about what is happening beneath our feet. A heat dome's relentless grip. To understand the current crisis, it's essential to consider the meteorological heat dome that settled over the western United States this summer, a large region of high pressure that traps hot air and inhibits the inflow of cooler air. In this pattern, heat is compressed, unable to escape. The 2025 heat dome has proven both large and persistent, driving temperatures higher and higher and helping to set widespread records from Arizona deserts to the plateaus of Utah and Colorado. As the heat dome lingers, thermometers across the four corners rise past 110, approach 115, and this year have reached 118 degrees. The intensity has led to reports of higher nighttime lows. When the sun sets, the land retains much of the daytime heat, and temperatures fail to dip to levels that provide respite. This means that not only are days harsh, but evenings too are suffused with warmth, offering little recovery for people, animals, or plants. Urban centers and rural areas alike have adapted as best they can. Residents shutter windows against the heat. Agriculture struggles with evaporating irrigation, and livestock search for shrinking shade. The relentless air makes work outdoors daunting and amplifies health risks, especially for the elderly, children, field workers, and those without robust shelter or access to air conditioning. What's striking now is the accumulating effect. As the heat persists, more of it penetrates the subsurface layers of soil and rock. Some scientists and weather agencies have reported monitoring increases in subsurface temperatures in certain locations that are higher than historic averages. While such measurements are subject to context and may not represent a wholly new phenomenon, the persistence and intensity of this heat event have prompted renewed scrutiny of thermal dynamics below ground. Is this buildup of underground heat simply a lagged response to surface extremes, or could there be deeper geological factors involved as well? These are questions that geologists, climatologists, and local residents increasingly wish to answer. Fire and drought, a perilous cascade. Heat has consequences beyond discomfort. It's a catalyst for ecological crises. Across the Four Corners region, the stakes in 2025 are clear. Wildfires, always a risk in late spring and summer, are now an ever-present danger. Abundant dry fuel, driven by dry winds, has set the stage for rapid ignition. It only takes a single lightning strike, common in summer monsoon storms, even if rain fails to materialize, to set off extensive wildfires, as seen recently in the western slope of Colorado and southeastern Utah. Once burning, the flames move fast amid parched landscapes and forests. The pall of smoke can linger for days, covering communities near and far, and pushing air quality to hazardous levels. Fire risk also closes historic and beloved landmarks, such as the North Rim of Grand Canyon National Park. With fire conditions so hazardous, the park has closed for the rest of the 2025 season, a sober reminder that normal summer adventures are now shadowed by climate extremes. Rural communities, often with fewer resources, face additional threats. Livestock must be moved, crops fall to drought, and water sources dry up. Groundwater stores are depleted faster than they can refill, and significant fires leave the soil bare, enhancing the risk of both subsequent drought and even flash flooding when rare rains return. This convergence of heat, drought, and fire creates a dangerous feedback loop. As drought dries vegetation, the risk of fire increases. Following fire, the loss of plant cover allows more sunlight to saturate and heat the soil, amplifying thermal loading both at and below the surface. Scientists are now watching with concern to see whether these processes can, over time, alter the region's equilibrium and perhaps affect deeper Earth temperatures as well. Geological mysteries. What lies beneath? Beneath the visible extremes is a world that has always held secrets. The Four Corners sits atop the Colorado Plateau, a region with a uniquely complicated geological past. The plateau is marked by uplifted sedimentary basins, ancient salt layers, remnants of long-extinct volcanoes, and thick strata of mineral-rich rocks. This area has been shaped by volcanic flows, deep aquifers, and shifting faults throughout geologic time. Most of the heat we feel at the surface comes from the sun, but the Earth itself generates its own warmth. Residual heat from planet formation and decaying radioactive minerals deep underground are always present, though usually slow to move upward. Under normal circumstances, the soil acts as a buffer, with temperature changes mainly reaching a few feet below the surface. However, prolonged and intense heat waves, such as those now hitting the Four Corners, can drive warming deeper. In certain areas where geological layers are thin, fractured, or laced with salt or ancient lava beds, heat can propagate more swiftly downward. Additionally, if deeper layers are unusually permeable, or if any geothermal features exist, such as warm springs, those zones may host warmer subsurface temperatures than the norm. Some geologists have noted historic geothermal features in the region, such as the San Juan volcanic field, and speculate about their local influence. Yet so far, no verified evidence exists of a new, anomalous, or widespread surge of heat rising from deeper Earth sources in the Four Corners as of 2025. Most subsurface warming measured ties back to extraordinary and persistent surface temperatures rather than to emerging volcanic or tectonic activity. Nonetheless, these observations underscore how complex and dynamic the relationship between surface weather and subsurface geology can be. Ongoing scientific studies are using thermal probes and temperature loggers at multiple depths to understand how far and how fast this heat is traveling underground, and whether any geologic formations may enhance or slow its movement. The human response, communities on the edge. For those who live in the Four Corners, adaptation is part of life. Centuries of habitation by indigenous nations, ranchers, and farmers have forged deep knowledge of drought, fire, and heat. Today, as temperatures rise and water becomes more scarce, communities are once again called to respond. Heat and humidity pose immediate risks. Health officials across Arizona, New Mexico, Utah, and Colorado warn of heightened dangers. Heat exhaustion, heat illness, and mortality risk all rise sharply with extended heat waves. Cities and towns open cooling centers and distribute water, striving to make relief accessible for the most vulnerable: elders, children, those without shelter or robust cooling. The drought compounds everything. The Colorado River, already strained by years of overuse and diminishing inflows, faces further pressure. Reservoirs sag ever lower. Some wells run dry or return less potable water. Farmers and ranchers adapt cropping schedules, shift to more drought-resilient species, or make the tough decision to sell livestock when forage evaporates. Community events move indoors or are postponed. Traditions adapt or go virtual, and people come together to update infrastructure and mutual aid systems. Amid these challenges, there are stories of innovation and solidarity. Some tribal organizations are reviving ancestral dryland farming strategies, optimizing water use. The science of heat, monitoring the invisible. Scientists watch, measure, and analyze the Four Corners region more closely now, as the unusual persistence of high temperatures raises questions on many fronts. To investigate possible underground changes, research teams deploy an array of instruments, temperature probes at multiple depths, data loggers anchored in boreholes, and remote sensing tools that track both surface and shallow Earth temperatures. Thermal sensors in different locations report changes in soil temperature that are greater than would be expected from historic air temperature alone, especially where surface readings have shattered records. Geologists overlay these findings with maps of soil type, rock stratigraphy, and known geologic features, seeking patterns that might explain or amplify the observed changes. Satellite-based thermal imaging also plays a role in painting the regional picture, mapping so-called heat islands, where both surface and near subsurface temperatures are abnormally high. These often coincide with either built environments, like dense urban areas, or with specific geologic formations that efficiently absorb and store heat. What researchers see so far is that the influx of heat is not uniform. It is concentrated in places with thinner soils, exposed rock, or minimal vegetation. Patterns tend to follow both natural lines of permeability, such as fractured sandstone or ancient volcanic layers, and patterns of human disturbance, such as construction or mining. Despite the intensity of the 2025 event, however, no evidence yet indicates a new or large-scale underground geothermal anomaly in the Four Corners. Instead, the majority of observed heat spikes underground. Ecological impacts, wildlife, and ecosystems under siege. As the heat and drought persist above and penetrate below, the region's ecosystems suffer. Iconic trees, pinyon pine, juniper, and sagebrush, are pushed to their thermal limits, and animal migrations shift in response to evaporating water and shrinking cover. Streams dwindle, wetlands vanish, and grasslands turn tinder dry, raising the risk of further fires. Wildfire, once a seasonal occurrence, has become a more constant concern. Burned areas lose habitat for birds, mammals, reptiles, and pollinators, disrupting the cycles of plant regeneration and animal movement alike. Ecologists are urgently studying whether these changes, fire, drought, shifting migrations, are tied merely to above-ground weather, or if they're being exacerbated by unusual warming in the ground itself. For now, most evidence points to extreme surface events as the main driver, but monitoring continues. A historical perspective, echoes of the past. This region's striking landscapes have always told of transformation. Uplifted mesas, volcanic fields, and deep canyons are products of geologic processes far older than any human witness. Sedimentary layers tell of ancient seas and deserts. Volcanic rocks recall eruptions millions of years ago. Indigenous oral traditions, meanwhile, remind us that cycles of drought, fire, and rebirth are nothing new in the Southwest. Archaeological evidence reveals that past societies moved, adapted, and rebuilt when water grew scarce or the climate shifted. Tree rings show alternating periods of hardship and resilience, while ancient irrigation channels suggest clever strategies for coping with environmental extremes. Today's confluence of extremes echoes those lessons. The geological past, once merely background, now seems closer to center stage as climate and geothermal questions intersect. An uncertain future, the Four Corners at a crossroads. As July turns to August, uncertainty reigns about what comes next. Will the heat subside, or will the pattern of prolonged and damaging extremes become the new baseline for the Four Corners and the wider Southwest? Can existing drought, fire, and heat risks be managed, or do they now pose persistent threats that will demand new strategies? Across the region, communities act in the face of challenge. Emergency managers coordinate wildfire response and distribute relief. Tribal governments and scientists share traditional knowledge and new data. Farmers test drought-adaptive crops. Policymakers draft water-sharing agreements and step up conservation efforts. There are hopeful stories, educational programs that teach the next generation about water stewardship, restoration work to heal burned or overgrazed lands, partnerships between indigenous groups and universities to share monitoring data. Mobile science units travel to the area's most remote corners, ensuring all affected have a voice and an opportunity to engage. Yet the land itself remains unchanging and enduring, a witness to centuries of adaptation. The record-breaking heat, vanishing water, parched soils, closed parks, and persistent fires stand as reminders that the Four Corners is now at a critical juncture, one where the actions of today will shape both the human and physical environment for years to come. What does the future hold for the Four Corners? Will the region find ways to thrive, Or will it endure further challenges as climate and geologic forces continue their interplay? The answers are not yet clear, but never before has the connection between Earth, sky, and human community seemed so urgent. As we await the next scientific findings and watch the natural drama unfold, we invite you to reflect. What fascinates you most about this region's evolving story? Is it the persistence of life along the edge of extremes, the interwoven histories, the still mysterious interplay of climate and geology? Let us know your thoughts below, and be sure to subscribe for deeper explorations of Earth's enduring puzzles. Together, we watch and wait, learning anew from a land that challenges, inspires, and endures, where Arizona, New Mexico, Colorado, and Utah meet